Hey guys, this is Ankit and welcome to the Google Cloud Platform Task Series. We are doing a list of basic tasks to get ourselves familiar with Google Cloud Provider, that is GCP. We are following the DevOps Engineer and SR learning path, also available at cloudskillsboost.google/paths. You can always refer to my repository, the Cloud Terminal 01/learn-devops to get more details. For today's task, we have the following objectives. We will create a deployment manifest and deploy it to the cluster. We will trigger manual scaling up and down of the pods in the deployments. We will trigger deployment rollout, that is rolling update to a new version, and also roll back the deployment to the previous version. Finally, we will be performing a Canary deployment. The total amount of time we will be spending will be around 12 to 15 minutes. So let's begin. Let's move on to our first subtask. We will create a deployment manifest and deploy it to the cluster. First, let's set the environment variables for zone and cluster name. So I'll copy this and let's set my zone as US Central 1A. Let's set the cluster name as standard cluster 1. Let's configure kubectl tab completion and cloud shell. Let's configure access to our cluster for kubectl command line. Now we'll be cloning this repository. The repository is cloned. Let's create a soft link as a shortcut to our working directory. And now let's change the directory that contains the sample files for this lab. So we have Nginx Canary, Nginx deployment, service nginx.yaml. We can open these files in the editor already available in cloud. So I have already opened this editor and these are the three files: Nginx deployment, service Nginx, and Nginx Canary. So in Nginx deployment, we have the name of the deployment as Nginx-deployment. This is the label. It will be running 3 replicas and we are using image with version Nginx 1.7.9, which will be using container port 80. So let's deploy this. Let's go back and deploy our Nginx deployment. So both our deployment and pods are ready now. We are running 3 replicas right now. Let's go to Kubernetes engine workloads page and increase the number of replicas from 3 to 4. We will click on the deployment, go to more actions. Let's go to scale, edit replicas, and let's change this to 4. It's in progress, and if we go back, we will see it's completed already and we have 4 pods running now. And over here, let's refresh and it's completed. We can actually scale the pods down back to 3 replicas by using this command. So let's again scale them back to 3. So we have 3 pods of Nginx running now. Let's move on to our next subtask. we will trigger a deployment rollout and deployment rollback. For that, we will be setting the image to use Nginx version 1.9.1. So we'll be using this command. Let's check the version now. Let's check the image version currently, which is 1.7.9, and let's change this to 1.9.1. And you will see that it has started updating. Only one pod is up to date now, and the rest are getting updated with new version. We have one which is already updated. Let's see the version of image in this pod. And it's 1.9.1. And now all pods are updated. To check the rollout status of the deployment, you can run this command, kubectl rollout status deployment. And since our deployment was already rolled out to new version, that's why we are getting this message, successfully rolled out. And if you want to check the revision history of deployment, you can run this command. And you will see that we have had 2 revisions so far, and we are currently running the revision 1.9.1. Now let's say we want to go back to previous revision of our deployment. For that, we can run this command, kubectl rollout undo deployment, and this will take us back to the previous revision. So I'll run this, and we can again check the rollout history. We will see that we are back to the first version, which was over here, and we can get the details of rollout history again using this. And now we are back to 1.7.9. All pods are again restarted as well with the new version. Let's move on to our next subtask, where we will define a service type in our manifest. We want to expose the deployment with this load balancer service type. So let's go back over here and kubectl apply-f service nginx.yaml. We can see that the service is getting created. It's of type load balancer, and the external IP is still pending, and these details are as per what we have specified over here. The service is created, and even the external IP is ready. It's listening on port 60,000. So let's do a curl request over HTTP on this public IP and port 60,000, and we see an Nginx homepage. We can copy this, and we will see the same Nginx homepage over here as well. Also, if you go to services and ingress section, you will see the same details over here. The external load balancer is created, and this is the endpoint. So let's move on to our next subtask, where we will be performing a Canary deployment. So let's go back to our editor over here, and this is the Nginx Canary.yaml. Over here we are deploying one replica, and in this case the version of the image is 1.9.1. The one which we are currently using is 1.7. Let's check the version. The one which we are using now is 1.7.9. So let's deploy the new version. And we see that there is a new deployment, Nginx Canary, which is having one pod of newer version. So now we have two versions of deployment running at the same time. In total we have 4 pods. These 3 pods belong to the first deployment that we created, and this pod belongs to the second deployment that we created. So when we hit this page, the question over here is, how does the service know which pod it should send the request to? In order to answer that question, let's have a look at the manifest files. In the service, we will see that it will send request to any pod which will have this label app Nginx. And if we see the Nginx deployment that was previously created, these labels are already present, and also in the Nginx Canary deployment, we will see that we have the same label which is created over here. And since we have less number of pods running for Nginx Canary deployment, less number of users will be redirected to this pod. Since we have 3 pods running for the previous version of Nginx, more users will be redirected to those pods. Now let's move on to our next subtask, where we will scale the first version of deployment to 0. So let's go back over here and scale the first one to 0. And we will see that this one is not having any pods now, and if we go back to this page, there is no downtime. Some of our requests are going to the new deployment and some are going to the old deployment. In some cases, we may have a requirement wherein we want all the requests coming from the same user to go to the same pod that addressed the first request from that user. This is where the session affinity comes into picture, and we can set the session affinity to client IP in this way in our service type Kubernetes object. This completes all of our subtasks. That's all for today. See you in the next video.